Alright, so welcome students. This is Lighted Brains Online Tutorial once more. This is section 2 of the Math 102. My name is James, also as you know. Now, in this section, we are going to be looking at, in the previous section, we talked about first principle, differentiating using first principle. But in this section, we are going to be looking at differentiation using what? The chain rule. The chain rule. Now, this is another way of solving a differential problem. Okay, chain rule. Now, what do we mean by chain rule? We simply call chain rule the function of a function. Okay, function of a function. Why do we call it function of a function? Let's see. Take for example, we have y is equals to x plus 1 squared. X plus 1 squared. Now, this is a very simple question that you can use any approach to solve. You can use your power rule to solve. You can use your chain rule to solve. And how do you know when to solve? How do you know when to use chain rule to solve a differential problem question? It is when it is in brackets. When you need to expand it. When it is all in brackets and it is carrying the power. Okay, I will explain why I said so. Now, looking at this, you can easily expand this, right? Because it's just 2. You can easily expand it because it's just 2. But what if it is 10? What if y is equals to, in bracket, x plus 1 raised to the power of 10? How do you now solve? Do you now start expanding into 10 places? No. So that is why we have chain rule, product from a function of a function. Okay. Now, I will teach you how to solve using product rule. But first of all, let me show you that you can also solve this problem using what? The power rule. And before you can solve this problem using the power rule, you need to what? Expand first of all. See, I'm trying to link everything so that you know that if we use chain rule to solve this, the same answer we will get if we also use what? Power rule to solve this. Now, let us expand. This is x plus 1, okay? X times x squared. X times 1, x. 1 times x. 1 times 1, 1. So we have x squared plus 2x plus 1. That is after we have expanded. So y is equals to this. Now, using your power rule, what do you get? You can differentiate x squared. This is 2, which is the power. The power will multiply what is at the front because there's a 1 at the front. So y is equals to 2x. If I subtract 1 from 2, I'm having 1. So if I differentiate x squared, I'm having what? 2x. If I differentiate 2x, this is a power of 1 up here. If the 1 multiply 2, I'll be having 2. Okay, I'll be having 2. Now, if I subtract 1 from the 1 here, I'll be having what? 0. And I told you that anything raised to the power of 0 is what? 1. So 2 times 1 will give us 2. Now, this is 1. We can also differentiate a constant. 1 is known as what? Constant. If you differentiate a constant, it is what? 0. So whenever you see a constant and it has to differentiate, you know that the answer is 0. So after differentiating this, the result we got is y equals to 2x plus 2 as our answer. So dy over dx, which means differentiating y with respect to s will give us what? 2x plus 2. That is when we use the power rule. So in such case, if you want to use power rule, we need to first of all expand. And after expanding, we go for the derivative. We get what? 2x plus 2. Now, let us solve this using the product rule formula. Using the product rule, which is the concept of today. Now, product rule, what does product rule mean? Product rule means function of a function. This is y, this is x. This is y, this is x. And this particular place is a function on its own. Okay? Now, say for instance, y is equals to, y is there, x is there. But x itself, x plus this one gives us another, see, x is a variable, right? X is a variable on its own. But the fact that one is adding to x makes it another expression on its own. So it means that x is a part of something bigger. X is a part of x can stand alone, yes, but in this case, x is a part of something big. Okay. Now, we can say let x plus 1 be equal to u. Let x plus 1 be equal to u. Meaning I can rewrite this thing as y equals to u squared. Okay? X plus 1, let x plus 1 equals to u, so that it can be easy for you to solve. Now, if x plus 1 is equals to u, if I replace whatever is here, which is x plus 1 with u, I'm having what y equals to what? U squared. Okay? Now, what is there for the chain rule formula? The chain rule formula is dy over the x is equal to dy over the u times the u over what? The x. Dy over the x equals to dy over the u times du over what? The x. Let me tell you what this simply means. Differentiating y with respect to x is equals to differentiating y with respect to u times differentiating u with respect to y. Very simple. Now, how do we do this? Look at this one. The first thing first. It said dy over the x is equal to dy over the u. Differentiating y with respect to u. Differentiating y with respect to u. If I differentiate this, what will I have? If you differentiate u squared, I'll be having what? 2u. Abi? 2u. Now, this will give me what? 2u times differentiating u with respect to what? X. Now, what is u? What is u? Don't forget that u is equals to x plus 1, right? So what do you get when you differentiate x plus 1? 1 is a constant. And I told you that whenever you differentiate a constant, you will get 0. X is x. When you differentiate x, you get 1. How? Look at it. This is x. If I say dy over the x, this is y equals to x. If I say dy over the x, I'm talking about, don't forget that x is carrying the power of 1. 1 times the 1 that is here will give us what? 1. Times 1 minus 1 will give us what? 0. Any to the power of 0 is what? 1. So 1 times 1 will give us what? 1. So it means that if I differentiate x, I'll be getting what? 1. Which is, so it means that du dx, which means differentiating u with respect to x will give us what? 1. Now, this is the chain rule formula, okay? This is what you use. This is the chain rule formula. So, our diagonal, we now have dy over dx is equals to what? 2u times 1. 2u times 1. Now, this is the part where we now start imputing what we get. What did we get? What is u? U is what? X plus 1. Okay? X plus 1. So, I can write this as and say dy over the x is equals to this 2. I'll put down the 2. What is u? U is what? You said let u be what? X plus 1. Times what? Times 1. Okay? Now, dy over the x is equals to, if I 1 times anything is that same thing. So this is out already, right? Because 1 times this is also this. So this is what dy over the x is equals to what? If I expand this, what will I get? 2 times x gets what? 2x. 2 times 1 gets what? 2. So dy over the x is equals to 2x plus 2. And that was exactly what we got when using the what? The power rule. That was exactly what we got when using what? The power rule. So, like I said before, when do we use chain rule? When do we use chain rule? We use chain rule whenever it is very, very hard, or it is more like it's not impossible, when it is very complex for expanding. Let's say, for example, we have this power 10 here. We cannot start using power rule because we have to expand, and in the process of expanding, we might make a very huge mistake. So that is why we apply the concept of chain rule, function of a function. Now you might come across this question in the exam: which of the following method of differentiation is called function of a function? A. Chain rule. B. First principle. C. Power rule. D. Quotient rule. That's a question. See, it's not all about solving. Questions might come in this aspect. So function of a function is known as what? Chain rule. So that's that. Now let's take a look at another. This is a very simple example. Let's take a look at another example to see how good we are in solving chain rule problems. Now let's take a look at one complex one. Let's say y is equals to 3x 3x plus 1 raised to the power 10. Okay, now we cannot start using the power rule to start expanding before we now differentiate. No, you are wasting your time. What we simply do is we use the chain rule. Now, this is why the first thing we do is we consider everything here to be a function. Okay, we consider everything here to be an expression, which is we can say let. Okay, let me write it here. Let 3x plus 1 is equals to u. So we are assuming that we are taking that 3x plus 1 will be equal to what? U. So anyway we see 3x plus 1, we are saying that it is u. So we can rewrite this and say y is equals to u raised to the power what? 10. Okay, y is equals to u raised to the power 10. And what is the formula for chain rule? dy over dx is equals to dy over du. It can be anything, it can be du, it can be dv, it can be ds, it can be anything, okay? Depending on what you want to use to replace what is here. I use u, you can use any alphabet. Times du over what? Dx, okay? So this is it. Now, dy over dx means let's differentiate with respect to x. Because what is dy over du? Dy over du, which is differentiating this with respect to u. What is dy over du? If I differentiate y with respect to u, I'm going to have dy over du is equal to 10 u raised to the power 9. And how did I get 10 u raised to the power 9? The power we multiply what's at the front, then you subtract 1 from the power. So when 10 comes to the front, I will have 10u. When you subtract 1 from 10, I will have what? 9. So dy over du is equal to 10u raised to the power 9. Get that down. Now 10u raised to the power 9, okay? Times, what is du over dx? Now, we want to differentiate u. Don't forget that u is equal to this, right? 3x plus 1. We want to differentiate u with respect to what? X. Now, what do we do? Just as we did the first one, if we differentiate a constant, 1, we'll get 0. If we differentiate 3x, what will we get? When we differentiated 2x, we get 2. See, it is reducing. If you differentiate x squared, you get 2x. If you differentiate 2x, the x will be out. You'll be having 2. If you differentiate 3x, the x will be out. You'll be having just 3. If you differentiate 10x, the x is out. You'll be having just 10. Simple. So if you differentiate 3x, what will be left? Just 3. Okay. So I'll be having what? 3 here. So it means that du over dx is equal to what? 3. dy over du, 10u raised to the power 9. Du over dx, 3. Okay? Now, this is what we get. Now, what do we do? Can we just leave it like that? No. Let's continue. So we say, okay. Okay, let's come up here. We say dy over dx is equals to 10. Now, what is u? What is u? U is what? U is 3x plus 1. 3x plus 1 raised to the power what? 9. We are putting it back into the equation now. Times 3. Okay? Times 3. Now what can we do next now? We multiply. This 3, we multiply 10. 3 is multiplying 10. Oh. We are not going to use 10 to expand this bracket. No, because of this power. So 3 is just multiplying what? 10. So we can say that dy over dx is equals to what? 30 3x plus 1 raised to the power 9. Very simple and very easy. So this is the result you will get when you use chain rule to what? To do for the derivative of this. Okay? Now, as I told you before, it is not all differential equation problem we can use power rule to solve. We cannot use power rule to solve this because of it is raised to the power of 10. You cannot start expanding in 10 places. That is why we have to introduce what? The function of a function, which is chain rule. Okay? So you will know when to use chain rule when the power is very big, when the power is very high. That's when you know when to use chain rule. And this is the formula for chain rule. Dy over dx is equal to dy over du. Like I said before, it is your choice to use u, it is your choice to use any alphabet. You can use v, you can use s, you can use your alphabet of your name. No problem. Dy over du times du over dx, such that if this du cancel this du, you'll be having what? Dy dx, which is the same thing as this. Very simple. So this is the second example I have given to you. And I am going to give you one more example, then you just try it on your own and drop the answer in the comment section, okay? So yeah, let me just give you this one. You're going to solve it and you're going to drop the answer on the comment section, okay? Now, see if you can solve, let's say y is equals to 4x squared plus 2 raised to the power 7. So do this and drop the answers in the comment section. Thank you. Okay, so let's take another example on the chain rule problem. Taking for instance y equal to 6x squared plus 3x plus 1 raised to the power 9. How do we do this? What's the approach we take for this? First of all, you need to identify which method you can use best. You can only use, not only, you use the chain rule method for this kind of problem because you see that the power is raised to the power 9 because it's great. You cannot start expanding. You cannot start writing 6x plus raised to the power 2 blah 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 in 9 places and start expanding. No, you take your time. So we're just going to use the chain rule approach on this. So what do you do first? Now, as I told you that chain rule is called function of a function, okay? So we have two functions in this particular expression here. Now, we have y equals to, we have this, also we also have this. This particular thing is a function, while everything here is power 9 is another function. So we have two functions here. So what do? You can say, let's take 6x squared plus 3x plus 1 to be a variable. Let's assign it to be a variable. So what variable do we assign it to? We can say let u be equal to 6x squared plus 3x plus 1. So we have assigned u to be 6x squared plus 3x equals to plus 1. So what are we saying? We are saying that y is equals to what? U raised to the power 9. Simple. So this expression is already written as this. Okay. So now what do we do now? What is the chain rule or expression? You say dy over the x is equals to dy over du times du over the x. What does this mean? I will explain again. Dy over dx, differentiating y with respect to x, is equal to differentiating y with respect to u. Now, how do we get differentiating y with respect to u? You are going to go, we have this, okay? You are going to look for the one that has y and u, and that is one you differentiate. This one does not have y, it only has u and x. This one has y, it has u. So we are differentiating y with respect to what? U. So to get this, we solve with this. Differentiating u with respect to x, you look for the one that has u and also has x, which is this one. So we are going to differentiate u with respect to x. So let's begin. Now, dy over dx is equals to dy du. If we differentiate y with respect to u, what do we get? It means that using power rule, it means that we are differentiating this thing here. And using power rule, remember that I said that the power will multiply the coefficient and then you subtract 1 from the power. So what this simply means is y is equals to 9 times u, 9 minus 1. And this is y is equals to 9u raised to the power what? 8. So this is what you get. This is what you get after looking for the y over what? The u. So y over the u will give us 9u raised to the power 8. Then the u over the x. Now, the u over the x, this is u and this is x. We are going to differentiate u with respect to x. How do we get that? We say, now, the u is equal to this. Now, the u over the x is equal to differentiate this, okay? Now, using the same power rule, 6 times 2 will give us 12. Fx, subtract 1 from 2, and that will give us 1. I can decide to write the 1, I can decide to leave it like that. If I differentiate 3x, I told you before, like I differentiate anything that has a coefficient, any coefficient that has just x with raised to power 1. When you differentiate it, you remove the x, when you remove the alphabet. Take for instance, if you have 9x, if I differentiate 9x, I will get 9. If I differentiate 7x, I will get 7. If I differentiate 2x, I will get 2. Okay, so very simple. So if I differentiate 3x, I will have what? 3. And again, this is a constant because it is not carrying any alphabet. Okay, so this is just 1. And I told you before that whenever you are differentiating a constant, it is equals to 0. Constant, like let's say 9, if you are asked to differentiate 9, it is 0. if you're asked to differentiate 8, it is 0. Differentiate 0, it is 0. Okay, so that's that. Now differentiating 1, I will get what? Plus 0. I can get to write it, I can start to do it. So this is what I will get when I differentiate u with respect to x. So this will give me this, and this one will give me what? This. So what am I going to do next? It's just for me to impute them into this stuff here. So dy over du will give me what? 9u raised to the power 8 times this will give me what? 12x plus 3. So what do I do next? Now, can you leave your answer like this? No. You're definitely not going to see. You're not going to see something like this in your option. What do you do? This is u. Don't forget that this is u. We still have u here. Now, what is u? What is u? From the beginning we said let u. We have assigned u to the word this. Now we want to reverse that assignment. Now we are reversing the assignment now. So u now is equal to what? 6x squared. So what do we do? Say dy over the x is equals to 9 brackets. Put u back. 6x squared plus 3x plus 1 raised to the power what? 8 times 12x plus 3. 12x plus 3. So the next thing you do here now is this 9 is going to multiply everything here. Don't forget, note, you cannot use this 9 to expand this bracket because this bracket alone is carrying raised to the power 8. This bracket alone is standing on its own. You cannot use 9 to expand this, except the power that this bracket is carrying is 1. That is when you can expand. But provided it is carrying a power of 8, 7, 8 from 2 above, you cannot use to expand. So what you simply do is this 9 will expand everything here. So you are going to say 9 times 12. Whatever you get, you put your answer there. 9 times 3, whatever you get, you put your answer there. So let's do this. So definitely 9 times 10 is 90. Now 9 times 2 is 18, and that will give me 108 x. Then 9 times 3 will give me what? 27. So this is what you get when you use this to expand this. Times, you can put it in bracket, times 6x squared plus 3x plus 1 raised to the power 8. So when you do for the derivative of this using chain rule, the result you will get is having is 108x plus 27 in bracket this is power 8.